This video is brought to you by Sporlan, quality, integrity, and tradition. All right, today we have a complaint that the kitchen's not working. They're also complaining that the restroom's too hot, the kitchen AC, I should say. I went downstairs. I'll pull up some pictures, but the grease filters for the hoods are plugged. I told them, you guys got to get those grease filters replaced. They're beyond cleaning. Then on top of that, again, because it's an air conditioning problem, I'm going to focus on the AC, but I'm not going to ignore the exhaust system too. So all their exhaust fans are working, but everyone has loose belts. Okay, so we went and took a belt count of everything. We're going to get extra belts. We're going to replace every belt, put spare belts on everything. You can clearly hear this one because it's spinning on the pulley. All the ACs need new belts. This one needs new filters. The other ones are okay. On top of that, we opened up the kitchen AC. When we first got here, first off, you don't ever just shut the ACs off, okay? We checked to make sure both stages were running. Both stages are running, but I opened this up and then I shut it off after that. But then I opened this up and look at this whole compressor. Look at this compressor and look at this compressor. It's covered in oil. Look at that. That's a bad sign. So something's going on. There shouldn't be oil everywhere on this thing. Something is amiss here. So look at this heat exchanger section, completely saturated with nastiness. The unit, the condenser, I have a really strong feeling that it's plugged up on the inside because this is a double road condenser. So where we're going to start, oh, and then the bar AC, which is what controls the restrooms, has high pressure codes. And while the condenser, you can see through it, it's very dirty, very, very dirty. So we're going to clean everything. We're going to start with a cleaning and then we'll address issues once we get past the cleaning point. But we're going to go ahead and pop the top on this unit, clean the inside condenser, clean out the compressor, run a leak check real quick. Sent someone to go get belts right now. Once he gets belts, we'll put all those on. And again, we'll start with that and then we'll work our way through. I don't really recommend it, but if you're very careful, I prefer pulling the tops on these first, okay? It's really a two-person job. One person can do it. You just got to be very careful. What I don't like is I don't like these folds. See how this is bending up? This is bending up. That's because people have tried to clean this condenser without pulling the top. They just bend the top out of the way, which sometimes you got to do, but I'm just not a huge fan of that. So we got the top off. Doesn't look horrible, but it's dirty. I can see it down in there. It's dirty for sure. So we're gonna get that guy cleaned. We'll get the evaporator sidewall cleaned. We'll do a quick leak search while we have it open. Kind of see if that oil is anything or if maybe that's just blowback from taking gauges off or something, who knows. Could also be leaking Schrader cores because these are the Cormax fittings, which is very common. You can see these filters are pretty dirty. We're gonna change these ones. So this coil has like a corrosive coating on it, or protective coating, I should say. So you have to be careful about the cleaners. This is going to be perfect for the Refrigeration Technologies yellow venom packs. But look at the stuff coming out of that. On the inside too, it's dirty. So we're going to give it a pre-rinse like we are right now. Get the big stuff off, then we'll put some of the yellow venom pack on there. Let it work its magic. But yeah, look at that. Just coming out pure nastiness. So yeah, we'll get pre-rinsed and then we'll get some cleaner on there. So this is the yellow venom pack by Refrigeration Technologies, or Viper. This right here is insane because you see right here it says you can get 9 gallons because this is pure concentrate, right? So what I have in here is filled up to about right here. That's going to do this entire AC and then some, probably even the evaporator too. It just depends on the setting you mix it on though. You don't want to put it on the most you know, the highest setting, but yeah, more than enough, and it's completely safe on microchannel coated coils, all that good stuff. So we're gonna get some of this on there. The key is put this on there and let it sit. Unlike some of the other cleaners, this is just soap. It does not etch the coil. Okay, so we're just gonna leave it on there, let it sit for about 10 minutes, then we're gonna rinse it off. So I still have plenty of cleaner and I've already rinsed this whole thing and the evaporator. But you can see how this stuff just sprays on nice and foamy, and then you just let it sit. I already sprayed the inside condenser. Outside, you can spray the compressors, just as long as the electrical components are covered up, because it's not going to hurt anything. So we're getting all that oil off that compressor and just letting this in. Sometimes you may have to do a second pass of this stuff. It's okay, you know. It's not like the blue cleaners that just strip everything away. They make one of those too, but when you're dealing with coated stuff, you don't want to get that on there because it's not meant for coated coils and things like that. But this stuff is completely aluminum, microchannel safe, all that fancy jazz. So we're going to want to rinse this from the inside and the outside. So I'm going to do the outside coil first because I can do, you know, you can get to all sides. And it's coming off nice and good. Satisfying rinse. It's definitely dirty. You just got to be careful when you're rinsing because, see, it's blowing into the other coil. So you got to make sure we get the other coil rinsed too. Oh yeah. It's coming through nice and clean. So that coil was just all black. You couldn't even see the blue when I first got here. So do that. And then once we get one side rinsed, we'll go from the inside out and rinse it too, like this. See, and then boom. But you just got to be careful because it's also blowing it on the other coil. So just got to make sure you get a nice good rinse. Oh yeah, that's coming out nice and good. Isn't it satisfying when you see these things clean? There's something therapeutic about cleaning coils, I think. All right, we're gonna run the leak detector over everything before we put the top on. And there was a bunch of oil on this liquid header right here, this actuator metering device. And if we go right here, I picked up a leak a second ago. There we go. Field piece leak detector for the win. This is the DR82 and it is 410A. It does pick up 410. So we got a big old fat leak on that liquid header right there. So we're gonna get some Viper Big Blue on there and see what that does for us. I did a once over here and I didn't pick anything up on here. Cormax fittings are #1. Those things leak all the time. So nothing on that right now. Terminal plug, nothing. So I'm not picking up anything over here. It's just on that actuator liquid header right here, I think. No, right here. There you go. Then you get a numerical display on this guy too. So I have it on turbo mode right now. See if we pick anything up down here. Down here, down here, nothing down here. I still got to leak check the first stage, so that was the second stage. And that makes sense because my first stage suction line was condensating and the second stage wasn't, which would make sense because they should both be condensating equally if they've both been running for the same amount of time. Nothing. I'm not seeing anything on the first stage, but we'll soap up the entire thing right now. Okay, we have multiple leaks. There's multiple spots where it's bubbling out. There's one right here. There's one down here. So we're gonna just be brazing a bunch on this thing. But that one's probably the biggest of them all right there. Probably see it a little bit better from over here. See if we can zoom in on that. There you go. Right in that area right there. So there's multiple leaks on this guy. And that's the second stage. I'm not really seeing anything else up here. So we're gonna finish assembling the unit. I cannot fix this today, but we'll have to come back, take the top off again, braze all those leaks up. We'll bring a dryer with us, some 410A. We're already pushing 3 o'clock and we go into overtime at 4 and they don't want to pay overtime unless they have to. So we'll put this unit back together and we'll come back out for this. But we still got to finish changing all the belts. I'm already done cleaning this unit. We need to clean that unit. And then we'll be able to focus on this when we come back. All right, we got this guy turned back on for today. Like I said, we'll be back tomorrow to fix the leaks, but I turned it all back on. Clean condenser, clean evaporator, clean filters, new belt, so it can breathe now. And then we'll also, we're gonna have to recover the gas from the second stage. We'll go ahead and recover the gas from the first stage too. Probably gonna get here early in the morning, knock it out before it gets too hot. For now, we're just finishing up. We changed the belts on all the exhaust fans. We changed the belts on all the ACs. We're cleaning the bar AC right now. Now, this one's not dirty enough and it's a microchannel condenser that we don't need to clean it from the inside out. It'll be fine. We're just gonna get the fine crap off the coil. But yeah, we're getting there. All right, we are back this morning. Pretty much brought the entire van up onto the roof. So we're gonna go ahead and recover the charge out of this guy, focusing on the second stage. We're gonna pressurize it with a crap ton of nitrogen and a little bit of trace R410A. And then identify all the refrigerant leaks, hopefully braze them up. We'll also probably go ahead and recover the charge out of the first stage too, since we got the machine here, just to verify the charge is correct. So we got to start. We're going to go ahead and rip the unit apart again, just like we had it yesterday. So pulling a quick vacuum on this tank. I had previously used this on an ice machine repair, and I did use 404A, but we used all the gas out of it. There was nothing left in it. So because 404, it was clean gas. I did an ice machine repair on an Isomatic. It was from that video. But because it had nothing left in it, we're just going to pull an evacuation on it. There's no problem. You know, let's say a little bit of oil came out with it. Well, 410A and 404 are the same oil, so it's no big deal. So we're just pulling our evacuation, get it down to sub-micron, and we're gonna start getting prepped over here, getting the gauges put on and everything for the recovery process. You always wanna pay attention to what's going on here. So we're getting ready to recover the second stage, and check this out. I've got pressure, but I have a core depressor on here that I didn't actuate yet. It's not even, yeah, it's not actuated. So it's not depressing the Schrader, but we're building pressure. So I open this up, close it, and let's watch and see if it builds up again. Oh, now it's gonna make a liar out of me. But it's building, so those high flow Schraders are leaking on that suction side. Yeah, for some reason it's not building, but that 34 PSI was, you know, I don't have it opened. So in our process, in our repairs today, we're gonna go ahead and replace these high flow Schraders because they do leak. Yeah, that's bizarre. I don't know why it's not building anymore. Huh, go figure. All right, well, we're just getting ready. We're probably done with the vacuum. Let's see. Oh yeah, 145 microns. Now it's normal for it to rise. All right, it's gonna take a minute, but we're good to go on this, so we're gonna get that hooked up and then start the process. All right, recovery machine is hooked up. We purged all the lines, clean empty tank, got the scale running. We're gonna go ahead and weigh out the gas, and then we'll get in there. We'll probably just leave ever so slight positive pressure and then put nitrogen on top of it. That way we can get in there and identify all the refrigerant leaks. If you follow the EPA's protocol for recovering gas, they want you to pull it into a vacuum to verify that you get all the refrigerant out. But when you have a system that has refrigerant leaks, you can't do that. So we're pulling gas out of here, and this system has leaks, so we can't pull into a vacuum because it would pull air into the lines through all the leaks. So you have to leave it, but we're gonna leave it slightly positive so that we put nitrogen on top of it and really pump this system up to find all the leaks. So factory charge on this guy for the second stage is 8.1 pounds. And we've only recovered about 5 pounds, 6 ounces. So we're definitely a couple pounds short. So we're just getting ready to put some nitrogen in this guy right now. Okay, we're pressurized up to about 250 PSI. And it looks like we only have one leak. It's gonna be right here. I'll come from the other side and see if I can get you guys an image of that. There it is right there. If the camera will focus. Right back in there. So I'm not really seeing anything else. Everything else looks really good. So we're gonna get in there, clean it up, sand it. I got my fancy brush again. Get you in there nice and good. And then we'll get that guy sweat up. In cleaning up the copper, we actually made the leak bigger. You can see it just bubbling all back there like crazy. I put a mark right here, that way I'd know where it was. So we're gonna dry it up and get on it real quick. The big blue does the trick. Okay, we're gonna unsweat this. It's not ideal, but it is what it is. We're purging with nitrogen right now too. It might flare out on us. No big deal. this guy to go this way. Always inspect your braze joints. Make sure they look tip top. That one needs a teeny bit more heat. It has a funky shoulder on it. Both of them just need a tiny bit more heat. They don't need any more solder. All right, so now we're gonna get on this last one, which is right here, and we're just gonna solder up this fitting real good. We're still purging with nitrogen, so. So you see, sometimes I'll do this. I beat it up really big, and then I'm gonna let the heat fall and melt it into everything. Give it a nice shoulder. Bring it around to the other side. Might as well. I'm just gonna, the areas around it, I'm just gonna lay some solder on it too. Just for giggles, to be safe, since we're heating it up. Looks good, got plenty of solder on it. Just did up all the stuff in that area. Nice and good, just to be safe. So we're looking good. We're gonna go ahead and pressure test and then do an evacuation on this guy. All right, while we were doing all that brazing, we had someone else recovering the charge from this stage right here. Okay, this is the first stage. That had the right amount of gas in it, 3 pounds or something like that. So with that being said, we never let that system go to atmosphere, okay? It's still sitting. It pulled into a vacuum, but the refrigerant boiled out of the oil, so we're still in positive pressure. With that being said, I'm gonna pull a quick evacuation on here. Technically, I don't have to because we never open the system to atmosphere, but we're just gonna pull a quickie real quick. We're not going crazy. On the second stage, we'll get my big hoses and we'll be all fancy, but this one, because it's not critical and we never opened it to atmosphere, we're just gonna pull it through the gauges, just real quick. Just get a little vacuum on it. We're not even gonna see anything crazy, so we'll let that run for a few minutes while we're working on cleaning up and strapping the dryer and stuff. You can see that I put a spoiling catch-all and it's bigger, so we're gonna have to strap it accordingly. We'll do that too. And yeah, so we're just gonna let this run for a few minutes, pull it down a little bit, and then we'll end up charging both of these at the same time probably. This is frustrating. My high flow Schrader cores, you know, you can't put normal vacuum hoses on there and you can't use a normal core removal tool, so you have to use these. These things are leaking. I tried to pull a vacuum and it was just, it sounded like it was sucking air and I was blowing oil out, you know, and it's these, because I just did a pressure test and it's nothing. I mean, we changed 0.4 PSI, nothing compared to the sound that I was hearing coming out of the vacuum pump. So Unfortunately, we're gonna have to go ahead and pull the vacuum through the manifold gauge set, and I'm gonna have to get some new Schrader depressors because that's frustrating, man. So we're gonna go ahead and hook up to the 3/8 hose on the manifold set, pull the vacuum, and then go from there. But I'm confident we don't have any more leaks. So significant change, like the tone of the vacuum pump is much quieter now, pulling through the manifold gauge set, just using the Schrader depressors. Now it's gonna take longer, and it's not a perfect vacuum. But you know, it is what it is until I get those new high flow Schrader depressors to replace this, so that way we can do this properly. Junk. We're gonna go ahead and put the top on because we know there's no leaks now. So this is a restaurant. I've shown this a while back, but while we're doing the evacuation, we're waiting for that, we're gonna be fixing some duct work because they've had other companies come in here and they replaced the grills, but they never installed tapers, so the ducts are literally just sitting here cooling the attic. So we're gonna try to fix all that. We got several of them in the kitchen that are doing that. All right, I just turned off the vacuum pump maybe 10 minutes ago, 15 minutes ago. We're in decay right now, slowly rising. We're at about 773. I'm pretty confident we're good. I'm not too much more worried about that. So we're gonna go through the process of charging this guy up now. We gotta charge both compressors though. So I think what we're gonna do, I don't know how I'm gonna go about this right now. I'll have to figure it out. All right, I figured it out. I'm gonna reuse what I can of the recovered refrigerant, but here's what we're gonna do. I'm working on the second stage, but obviously the first stage is gonna start up first, and we need to charge the first stage too, but I don't wanna take the gauge hoses off of the second stage because we pulled such a deep vacuum on it. What we're gonna do is we're gonna put an even amount of refrigerant in there. We're just gonna put in maybe 3-4 pounds, so that way it's in positive pressure. Then we'll write it down. Then we'll jump onto the first stage and go from there. Now the first stage, I was able to take the gauge hoses off without introducing anything because I had the Schrader core depressors on there. So I was able to back those out, boom, and then pull them off. So we're just going to, I already zeroed it out. We're already opened. So we're gonna add refrigerant into the high side. Let me close off the low side. Add a couple pounds into the high side. We'll just let it take as much as it can, but we'll stop at an even number. And then that way, you know, we don't get lost on how much gas we put into it. It's kind of hard to show it on camera, but we're charging the other compressor now. And this compressor was in a vacuum. So the question is, how did I get my gauges on there without disturbing the vacuum? And what I did was I cracked the ball valves. And while it was spraying a minute amount of refrigerant out, that's when we put the gauges on. So that way there's always positive pressure pushing on it and it's not pulling this out or anything like that. So we're currently charging this one. And this is the one that we're gonna start up first. I disconnected the second stage, so we'll put the panel on, start it up, and then finish charging the first stage, and then we'll jump over to the second stage. And then we still gotta strap that dryer up back in there too. But so far so good. Just got a guy downstairs doing that ductwork repairs and fixing as many of those. We're still gonna have to come back for a few registers in the cook's line where they're busy, but we're getting all the other ones knocked out. Kind of put the panel up there a little bit. We're adding refrigerant on the low side. It's running now. I did have to jumper it out, but first stage is running. We're just adding refrigerant. We're trying to get to 8.3 pounds. So we're almost there. And then got an extra drum for the remainder that we need for the second stage. So a little bit out of time. All right, we're having problems here. Here's what we're doing, okay? I have Measure Quick on my phone. Lost my train of thought here. Here we go. I'm setting it up. First and foremost, let's go to my toolbox, okay? I have everything mapped. Low pressure 1, low pressure 2, high pressure 1. We have a 2-stage unit, right? And I realize that in Measure Quick, you have the stage, circuit, whatever, the name's different, but this is a 2-stage unit, 2 separate stages, okay? 2 separate sets of probes. So I've got all the probes all on here. Everything's fine, okay? I go into multi-circuit, multi-stage. I'm all confused on, I get it. The only thing that tells me is 1 set of probes. So we have multiple sets of probes for 2 to 4 compressors. So we click on this, we choose 2 circuits, okay? Now, it starts on circuit 2. When I click on circuit 2, it doesn't let me switch to first circuit. What am I missing here? All right, I don't know what else. I haven't even profiled everything yet. Oh, you know what? Well, let's try this. But it's interesting that it starts on second stage. So let's change it to 2 circuits. Let's change it to package unit. variable airflow. This is a, what is my tonnage on this guy? Come over here. This is a 7.5 ton. It's a 008, so it's gonna be a 7.5 ton. All right, we're a fixed orifice metering device. Just correct me if I'm doing something wrong here. Everything else is auto-calculated. I'll leave the superheat and everything where it should be. It's a 13 to 16 SEER. Continue. Now we go, okay, so now it's letting me switch that, but now I gotta do everything. Oh no, I don't need to do it for all of them. Nope, yeah, we gotta change it. 7.5 tons. It's weird that you gotta change it for each one. Continue. Okay, so, oh, and see, yeah, that's weird. Okay, so you gotta set it as a piston for both of them. Okay, it's interesting. All right. So now, okay, I see how to switch it, but it's kind of weird that it started on second stage and there was like nothing there to tell you that. But okay, we're gonna finish going through everything now. All right, we're setting up. I'm all probed up. We got to go into my Honeywell Jade controller. You guys aren't gonna really be able to see this, but well, I guess you can. Let me get in here. So we're gonna go into set points. It's gonna be kind of hard because of the glare that you guys are gonna be seeing here. So we're gonna go into set points. I'm gonna find my minimum outside air position. It's set at 4 volts. We're gonna change that down to 2 volts, so that way the outside air damper closes all the way. So we want that closed for troubleshooting purposes. That way we can go through the unit and verify everything is working properly. So outside air damper is now closing, and we're just gonna give it a little bit to stabilize out. I've got Measure Quick pulled up on my phone. Both circuits, we can see them all. So we're gonna give it some time before we start playing with anything. I'm having some airflow issues and I wanted to inspect the ductwork. This is my return. Look at how smashed that return is. We've got one duct right here, but even up in there, like they're smashed through a hole in the wall too. That's my supply, that looks decent, but this return is no bueno. That's horrible. Look at that thing. Dang. And we barely got any airflow, and the return air grill is really dirty too. Yeah, what a mess. I'm just looking at the supply stuff. This guy's barely moving any air. This place is a joke. All right, this place is a mess. The ductwork is just horrendous. We're having really low superheat when properly charged on both circuits, and airflow is like non-existent. We have a 27-degree temperature split. It's saying airflow is really low. So what we're gonna do is we're actually gonna open up the outside air damper. We're gonna go to minimum position set point. I know you guys can't see it too well. We're gonna open that back up to about 5, and we're gonna see if that changes our superheat and changes our airflow. And if it does, it just further proves my point that we're not getting enough return air. We're gonna open that guy up to 5. That's gonna be almost all the way open. So that's gonna bring a lot of outside air, but it's gonna take a few minutes. I'll come back on here in a sec. This is still giving us problems. It's not fixing all the airflow, which kind of leads me to believe it's on the supply side too. So we're gonna have to come back in the morning. We've got the AC running. It's cooling down in there, but I'm just not getting the airflow that I want, and my superheat's too low on first and second stage. It's a mess. I went out like into their some other parts of the restaurant too, and the supply air diffusers are the same, where the ducts are just sitting inside of them and they're all jacked up. So we're gonna have to investigate the ductwork some more, but the unit itself is operating as best as it can. I mean, with limited airflow and stuff. So we'll definitely be dealing with the ductwork later. All right, what am I doing wrong here? We're having airflow problems too. This is why with the multi-circuit, everything gets jacked up, and I just don't understand what's going on here. And I realize I'm calling it the wrong thing, whatever. All right, so look. I have 2,200 CFMs of air, okay, estimated, right? Temperature split, but I'm on single, okay? When I change it to multi-circuit, multiple sets of probes for multiple circuits, 2 to 4 compressors. Okay, 2 circuits, system info, piston, that's all fine. Number of circuits, there's 2. Continue. Okay, now we're showing 21 CFMs per ton. Okay, I get that. But my airflow is 315 CFMs. Why? What is going on here? So if I go to circuit 1, I'm confused on what am I missing here? Why is this so difficult to calculate the airflow? We shouldn't be on split, but I don't think that's going to make a difference here. This doesn't make sense to me. So if I get out of this and just go to AC heat pump and then change it, all of a sudden I can see 2200 CFMs of airflow. So I don't get it. All right, we definitely have some airflow issues, but some of my stuff is going on with Measure Quick too. I was trying to use multi-circuit on Measure Quick and I got out of multi-circuit and I'm actually seeing 2100 CFMs of airflow now, which is still low, but it's a little bit more reassuring than seeing 300 CFMs of airflow. So there's something funky in Measure Quick. I don't know what it is. I haven't had very good luck with the multi-circuit, multi-stage, whatever you want to call it. But anyways, we're back on normal mode. We're just looking at one circuit. My superheat is still low. My temp split actually is about where it should be, to be honest with you. If you look at the temp split, it's calling for 23 degrees and we're at 25. So that's not too bad actually. We still want to fix the ductwork issues though. So we're still gonna come back for that, but the unit is working. We're gonna close this one out and then we're gonna talk to the customer about correcting a bunch of ductwork stuff more than what we already did today. So
look at the inside of that return duct. There's like inches of, it's just full of grease. The whole duct needs to be changed. That one's better. Still nasty as fudge though.
So it's always about the big picture, right? You know, looking at the big picture, when the customer allows it, we have to be careful with that, right? When the customer and your company allows it, looking at the big picture can help you with your troubleshooting. So I was called about their kitchen AC and I didn't want to ignore the fact that maybe the exhaust fans weren't working because that can affect the heat in the kitchen. So first and foremost, I found all their grease filters were plugged. It's hard for you guys to see in the pictures that I threw up there, but they're beyond cleaning. Those filters are impacted and with hard grease, the customer hasn't been cleaning them properly for so very long, it's time to just replace them. So that's one thing. We can't ignore that. Then we got the customer's approval. They do reactive maintenance here. They're not doing preventative maintenance. So we changed every belt on the roof, cleaned the condensers, got all that going. So once we did that, then we started diagnosing the kitchen AC. Actually came back the second day after I had a general diagnosis and repaired the issues. Ran into some vacuum issues, which is life. That's how it happens. Tools leak, they get worn out, different things like that. It's important that we know how to interpolate that data and make something of it, right? Same thing when I ran into issues using Measure Quick. It's about knowing when using digital tools and stuff, you're being given wrong data. You can't just blindly trust an app because an app tells you to do something, okay? You have to be able to look at it and say something's not right here. So I found some quirks in there. I was able to work around it. We got the unit up and running. But I think it's so important to know that we can't just go in there and blindly trust something because it tells us to. I still am a firm believer in digital tools. Digital tools are revolutionizing this industry, but they're not replacing us. They're just potentially helping us do our job easier. We still have to be able to look and say, wait, this is not a correct reading. Something is wrong here. So you can't blindly trust digital tools, okay? Now, I wanted to address something. I gave a tip about recovering and using the EPA rules because the EPA wants you to pull a system down to, you know, so many -30 whatever inches of mercury or so. I don't remember exactly what the EPA statement is, but when you're recovering refrigerant, they want you to pull it all the way down, basically to make sure that any refrigerant boiling out of the oil is out of the system, right? When you are recovering refrigerant that you are going to reuse on a known leaking system, you can't do that because if I pull down to the EPA spec, then I'm going to contaminate that refrigerant with air because if you're simply trying to pull and the system has a leak, you're just going to be pulling air into that refrigerant and pumping air into it, okay? So that's the point I was trying to make. Plus, on top of that, I was going to be doing a leak search on the system, so we still wanted to have some vapor in there so that way I can put nitrogen on top of it, which is EPA approved, okay? So keep that in mind. Again, we don't get tunnel vision when we're doing this work. We have to think and pay attention, make our job more efficient, okay? So I'm not perfect. I make mistakes just like the next guy. I'm just trying to share my mistakes so that hopefully you guys can learn from my mistakes, right? I really, really appreciate you guys making it to the end of the video. It's amazing the support from you guys. Check out my website, hvacrvideos.com. Subscribe to the channel. I've got merchandise available on there. In the show notes of the video, there's all kinds of valuable information, links that you can help to support the channel, that kind of stuff. I really, really appreciate you, and we will catch you on the next one, okay?